Delta Force, you are go for Operation Clean Gut. I want that gluten, zonulin, glutathione inflammation eliminated now.
In this video, I'm going to be talking about all of the different effects, or not all, but some of them, that a gluten exposure or ingestion has, even on the immune system and how the immune system functions. Okay, so what happens after gluten is ingested? Zonulin ends up modulating tight junctions. So they are called occlutin and claudin, and increasing intestinal permeability, or in other words, leaky gut, because gluten, especially in sensitive people, triggers this zonulin secretion in the gut. Okay, a real huge issue with gut permeability is that LPS, short for lipopolysaccharides, can pass into the bloodstream. What that ends up doing is that it binds to toll-like receptor 4, or TLR4 in short, on macrophages. So macrophages have toll-like receptor 4 as well as other innate immune cells. But the problem is that chronic inactivation of TLR4 leads to macrophage exhaustion. Well, what that's going to do is that macrophages, they're not going to be able to do phagocytosis, or that's like a word for the engulfing attack that macrophages do on, let's say, pathogens and cancer cells. So increased gluten ingestion over time will weaken the immune system. So the real issue here is that the macrophage dysfunction, because of increased or ongoing gluten ingestion in the diet, such as pizza. Gluten is in a lot of breads as well. It's very common in pizza. Well, if you look at the food ingredient labels, you'll find gluten there. Even if it doesn't say gluten, gluten can take other forms. There's even gluten in rice, surprisingly, but it depends on the form of the rice. I think that jasmine rice doesn't have gluten. So the real issue here with the gluten and the way it makes the macrophage dysfunctional is that it impairs the eat me signaling. Because normally macrophages, they recognize, like, let's say, apoptotic cells via eat me signals like calreticulin. Because like, let's say, a cancer cell exposes the calreticulin, or CRT in short. So that's exposed on the surface, and the macrophage is supposed to see that, and then that signals the macrophage to engulf the cancer cell. But that is dysfunctional because of gluten. Okay, now maybe the worst part about chronic gluten ingestion, or eating gluten all the time, is that a lot of immune functions are lost because the CD14 is cleaved off of the toll-like receptor 4. Now, the reason this happens is because the bacteria, lipopolysaccharides, created by gluten, is basically binds the CD14 repeatedly. What that ends up doing is that it upregulates NF-κB, and then that creates these proteases called ADAM, and then that cleaves off the CD14 off the toll-like receptor 4. The CD14 has to be on the toll-like receptor 4 for the immune functions to work. But with the CD14 cleaved off, that means that the immune functions are lost. Okay, so basically there's this important immune triad which gluten disrupts, and that is CD14 stays on toll-like receptor 4, allowing toll-like receptor 4 to interact with TRIF, or TRIF for short, but gluten disrupts that triad. Okay, this part has to do with viruses, because once that TRIF or TRIF signaling is reduced, there is also a weakening of antiviral surveillance, since the immune system is supposed to look out for like viruses, to stop viruses from invading the body. Another major, really important immune function is also lost, and that is the formation of C-SMAC, P-SMAC. So basically, if that succeeds in its formation, that pretty much means the end of a tumor. But so it seems that gluten can help a tumor escape immune attack. Okay, so basically, like the PSMAC is basically an actin ring that surrounds the C-SMAC. So the C-SMAC is like the lighter that puts on the flame. The P-SMAC basically doesn't let the flame go out. Okay, also, one of the best foods to support PSMAC formation is a nut, pecans, because pecans support actin polymerization. And as I mentioned before, the PSMAC is made of actin. So anything that helps actin polymerization will help the PSMAC. Okay, now some other issues with the CD14 being cleaved off because of atom protease is that it ends up floating around in like plasma and tissue fluids. So it floats around freely. So it's called SC CD14. And what it does is it expands lipopolysaccharide sensing to new cells. So another issue with this floating SCD14, that's because it's been cleaved off, is that it sustains inflammation at low LPS levels. So even tiny LPS amounts become bioactive, let's say from even just a little bit of gluten. So SCD14 floating around in the bloodstream raises biomarkers of metabolic inflammation, autoimmunity, which is pretty much a tissue being attacked, or the body attacks itself with, let's say, T cells. Um, Also, a cardiovascular risk and celiac disease activity, which is well known and well documented from a gluten ingestion. Another issue with constant gluten ingestion is that since the macrophages eat me signals detection like systems are disabled, uh, that dying cells are not cleared. And there are like a lot of problems with the dying cells not cleared because macrophages, their responsibility is to clear and engulf dying cells, but they can't since gluten disables the macrophages. Now, some of these issues with macrophages not clearing dying cells is consistent barrier dysfunction in the gut, including in the lung and in the liver, but I'm more focused on the gut barrier. So, like, that means increased permeability and leading to a self reinforced feedback loop because the gut being permeable and leaky in the first place was the very cause of why the macrophages weren't able to clear the dying cells in the first place. Also, another major issue of macrophages not clearing dying cells is increased oncogenic risk due to failure to clear senescent cells and DNA damaged cells. So macrophages are responsible to clear those, but they can't do that because of gluten. Also, DNA damage is also related to cancer risk. Another major issue of macrophages not clearing dying cells is ECM deposition, which could impact immune cells' ability to be able to enter the extracellular matrix to battle and fight off cancer cells. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.